Let me just get everything prepped up. Full screen that. And we can get started. So welcome everyone to Fly with Flutter Part 2. Hopefully you're here for Part 1. If not the end of the world. That was a lot of setup stuff, some introduction to some of the ideas of Flutter, but you don't really need that for this. This is just teaching you a bit more about some of the basics of actually coding with Flutter and some of the other things alongside with that. So a quick overview. So we are going to be going over some file structure, some widgets and widget trees, layouts, debugging, testing, and deploying. All right, so first up, I'm going to explain writing Flutter code. And just to give you a quick preface, you're going to hear the word widget a lot. So before I explain what widgets are, let's just go over the file structure. So these are the basic files that are going to come when you build your Flutter app. So if you do like Flutter create app name or whatever, these are the file structures that's going to be built for you for your Flutter app. So just a quick rundown is really easy actually to focus on because most of these you don't have to worry about. There's literally going to be one file or one folder that you're going to be working pretty much the entire Flutter app in, and then a couple other things you have to pay attention to. So the .ideal folder, some configurations, again, don't have to worry about it, thankfully. The Android and iOS folders, so when Flutter compiles, it produces native Android code and native iOS code, and they'll be put in their respective files, which rarely have to be edited directly. If you have to do things like connect Firebase or something like that, you might need the Android ID or the Apple ID of your project, stuff like that. So you'll have to look in those folders for those things, but you don't have to write in them. You pretty much don't really have to look in them unless you're setting up your project. You can ignore them for the most part. The build folder you don't have to pay attention to at all. That's for deploying. That's what the websites or the phone apps are going to be looking at for when Flutter builds. It's going to be looking in the build folder for the files that it needs. But all the output is handled by Flutter. Lib is where we actually are going to be writing pretty much all of our code. So this is where all the Dart files go that you're writing. This is where our main Dart file goes. It starts our Flutter app and all that stuff goes. That's where pretty much 99% of our work is going to be. And then test, Ray's going to go over some automated testing, but of course they're going to just go in the testing folder, kind of self-explanatory. So git ignore, for those of you that aren't really familiar with Git or GitHub, Git is what just kind of tracks your files for a, to keep track of them, for structuring them, organizing them, letting you share them with other people. What a git ignore will do is it's going to allow you to specifically ask Git not to track certain files. So even if you say, oh, add this to the tracked files, it'll be like, all right, no, I know I need to ignore this one. And you would do that for something like that has secret keys, passwords, any sensitive information that you don't want published to GitHub or to be tracked by other people. Finally, you have some, general ones like metadata, packages. In this case, the name of my project is flutter_demo. So you'll have that IML folder. It'll just be named whatever your application is called. It's all just info managed by Flutter. Again, you don't have to worry about it too much, just some metadata like that one file suggests. Pubspec.yaml, that's actually kind of an important file. So it lets you configure dependencies, fonts, images, all that stuff. So when you add configurations, like let's say you want to add a new library or something like that, you're gonna go into your pubspec YAML folder, add it as a dependency, and then you'll do like Flutter pubspec get or something like that, and it'll download all the dependencies, things like that. Usually, if you need something, the instructions will tell you how to edit your pubspec.yaml file directly. And YAML is just the way the file's structured. So it's something like JSON, something like HTML. It's not like something you program in, quote unquote. It's just the way the file is structured with its spacings and all that. And it's pretty clear once you open it with the information, the boilerplate that's there, like how you can actually structure it yourself. Pubspec.lock is a file that, while important, you don't have to actually edit yourself. It's just generated by the YAML file. So it's a more verbose output of all the dependencies and things like that. You don't have to pay attention to it. And README is simply just something that you would click on if you wanted to read. So it has information for displaying stuff about your project, maybe to other users, maybe like instructions, stuff like that, whatever. Now let's actually get on to Flutter. So one of the most important things in Flutter is called a widget. So everything is a widget in Flutter. So I'm going to be using this word a lot. So the entire user interface is just a composition of different widgets in which you specify the view of that component by passing in, I don't know, certain configurations, like maybe like saying the app bar is blue, something like that. And at a code level, each widget is just a Dart class that returns a component to be rendered. So the app itself is a widget which holds individual page widgets. And each page will probably hold its own set of widgets to render. So everything is a widget. So if you look at the phone right here on the right, this is the demo app that it gives you. And we'll look at a more in-depth example of what the exact widgets are. But the app itself is a widget. The home page is a widget. The app bar, the text, the plus sign, the button, they're all widgets on the home page. So essentially what happens is your program is going to say, give me a widget, and then that widget is going to be the app. And then that app is going to hold a bunch of other widgets within it. So it's each like component or building block of the application. They call them widgets in this case. So what's a widget tree? So if you can kind of think of what I was saying, so it's all the building blocks. There's a root of the tree, which is your main application itself. And then the tree, which is the structure of your program, is going to hold all those other components built on top of each other. So the root will then go into the different pages. Each page will have different components. Each component might have subcomponents, et cetera, et cetera. And I'll show you what a root tree might look like. And when Raymond debugs programs later on in this presentation, you'll see how you can actually see the root tree without having to explicitly build it yourself. So a Flutter app starts the rendering. This is just some code from the root widget, which is the app itself, like I said. And the actual function is run app, which is in the main.dart. So in main.dart, there's the main function. And that's where the Flutter app actually begins. So it calls run app, and then you pass it in the app name, the name of your root widget. What that's going to do is that's going to call inherently build, which what the build function is, it's just going to return a widget to the calling function. So it's going to, the run app function is going to call the root widget. It's going to call its build function automatically. And then that just starts a chain of, if I'm building the app, then the build function on my app might have a couple other widgets that it's calling, and then it'll call their build functions. It might call a couple other build functions, and then you can see how it starts branching off from the root to render a bunch of different components to the page. And that just keeps going until the full app is rendered, essentially. So if you want to look at the tree structure right here, this is the actual tree of the default Flutter app that you get when you initially build it. I personally find like when you first look at the code, like right when you open the Flutter demo, there's a lot of comments, a lot of stuff, which is helpful, but it can still be a little daunting because, it's just so much text on the screen. You open it in your IDE, all of it's colored differently. You're like, what does this do? What does that do? I have no clue. But I think when you visualize it like this, it actually makes it a lot easier to understand exactly what's happening. So first, at the very top, you have the app itself. And then you have Material app, which if you remember from the first one, if you weren't there, it's fine. I'll explain in the very next slide what Material app is. But Material app is just, has some nice preset styles so you can make things look nicer without having to manually customize widgets. So it just has some preset widgets that you can choose from, and a lot of which I choose to use in here. Then you have the home page, which is just our customized widget, which is going to hold everything. So that's the page itself. My home page is just the name of the widget. It's not one that's preset, whereas something like Scaffold and Material app are preset widgets. And that can come from different kinds of documentation that you'll see. You'll know where all those come from if you look at the docs that you're using for the library. So then you have a scaffold, which is just a widget that makes a nice skeleton structure for your page. So it has different spaces for, the content, a header, app bar, footer, body, whatever. The scaffold will actually have multiple widget children, which is split into an app bar at the top that has a text widget reading Flutter demo homepage. So the app bar itself is a widget, and then that contains a text widget that reads that Flutter demo homepage right here. So that's one of the roots done. So we now have a leaf, which means it's just the end of our tree. Now we can move on to the other child, which starts with center and then column and then two text widgets. So what is center and column? So it's actually, rather than a widget that's rendered and like visualized, it's just creating a structure for its children. So we have a column, which is another structural widget, which is just a different kind of structure. So you'll see how layering structures together. So center says it's the center of our page. Column means it's the middle column right here. So you can see how when you layer it together, you can actually get to a pretty fine-grained structure of your program. So I can tell exactly where I want it to go. And you can, put different spacers in between. I'll show you that in my demo. That kind of lets you do, even pixel movements between different widgets like that. And then finally, we have those two text widgets, which is you have pushed the button this many times and then the number of times you've pushed it. The reason those are separate is because one's stateless and one's stateful. Another thing we'll get into in just a couple slides. Just trying to introduce you to everything. So if you're not following exactly what all those vocab words means, that's fine. Just focus on the fact that the structure on the tree structure itself. And then finally, if we go back to the scaffold, you can see we have floating action button, which is this blue button right here. And then within that button, it has an icon, which is that little plus sign right there. And that's the whole app. That's this entire app by itself. Of course, when you build an app, it's going to be a lot more complicated than this. There's going to be, this is just one page right here. And this is a pretty simple page on its own. So it'll be a lot more depth. It'll have a lot more branching. and it'll have a lot more details to it when you build it, but it still is nice to visualize it because it's very clear to see where things go and what, you can add arrows like if, else's and stuff like that, what gets rendered, if it's conditional rendering, all things like that as you get more complicated. Let's talk about material design because that's something that I touched on before. And essentially what it is, it's the library that has a bunch of pre-made widgets that's actually produced by Google with lots of nice visuals, structures, and different rooms for customization. So I absolutely love UI libraries. For Flutter, material design is very modern and it can get you far just using the base widgets. And it'll even let you customize it further, like I said, which is even greater. In my opinion, there are a few things more painful than designing a front end from scratch. So if you ever done like plain CSS, plain HTML, you know how awful that can feel. So using UI libraries like material design makes it easier. It makes it look, it's actually really cool because it makes you feel like you're an artist because you're producing these beautiful applications without having to go through the nitty gritty designing of the pieces themselves. So you get to just plug them together. It's like building with Legos. Thank you for making it out. Hopefully you will check the recording. So it's very useful for making these super clean and beautiful user interfaces without having to design the components from scratch. So don't reinvent the wheel. It's what I was just saying. And one more thing I will point out about UI libraries is that the documentation contains a list of all the different widgets you can choose from. So there's tons of different use cases, options to explore, things like that. Just all sorts of things that these documentation holds, which is really useful for actually building. The documentation for UI libraries is usually really, really nice to use. And finally, we have stateful widgets. I touched on this a little bit earlier. So the idea of state is a persistent data or information used by an app. So if you ever heard of the term save state, that just means it kind of saves the current information with the app. So if you ever want persistent info, you ever want something to be dynamic, you're going to be using state. So something that is stateless will go back to the default page every time you refresh it because it doesn't actually save that current state, quote unquote, of the application. So an app state can hold things like currently loaded resources, authentication tokens, etc. But in Flutter, a widget itself can have state. So it can have things like if you have a text box, it'll have current user inputs for things like text fields. Maybe if a widget is currently loading, you can have a loading bar. So you can check that with its state. If you want to keep count for button presses, like what the demo does, you can do that. So if state can do all this, why would we have stateless widgets? Well, a Flutter application is made up of many, many widgets. Not everything needs to be dynamically have dynamic information, and it makes it a lot messier for coding wise if everything is stateful. It makes rendering wise, it can make it a bit less performative. So anything that's going to be static information needs to be can be stateless, and anything that is going to have any sorts of changing, if you're going to be rendering it dynamically, if you want to save the information, it should have state with it. So that's the general rule of thumb. And then you'll see in the code, I'm about to go to the demo, a stateful widget is broken down into two classes. So I said earlier, a widget is just a single Dart class. In the case of state, you break it out into two. You break it down into the widget itself and then the state itself. And the reason we do this is because widgets can be re-rendered if any external input changes, but that would also replace the state. So we just want to separate it so we could have the widget itself and then the state that we manually control. So they're not connected to each other. That's pretty much what state does. So we're going to look at a demo right here. And the demo is just kind of me going through. So I'll pull this up. Whoops, there we go. So this is the demo. I'll explain some of the code. It might look a little complex at first, but hopefully as I'll go through it, it's not super difficult. So the first thing I do is I'm importing that material package to use material design. I'll go through the code and then I'll show what the app looks like, I guess. So the first thing I'm doing is I'm importing material design. What that's going to do is going to let me use material app and all those different pre-made widgets that I talked about earlier. I also imported dart.math, which is something that I'm using to use just for the randomize function, which goes into the color thing. So right here, the colors, don't worry about it too much. This is just how I'm customizing some of the colors for the app bar and things like that. When you use material app, sometimes you're gonna have to use a map for colors because it uses themes rather than single colors. So you need different values. Again, don't focus on that too much. If you ever really want to get into Material App and you want to learn on how to make your own custom colors that aren't included with Material App in itself, there's really easy tutorials. I just Googled this and did it in like a minute. So it's not too bad. The first thing we do, this is in main.dart. So we have our main function. This is where our app enters. So we call run app. This is that function that we're going to pass in our main widget, our main app, and it's going to call the build function. So if we see what my app is, It extends the stateless widget class. So if you're familiar with Java, you'll see all this class inheritance stuff. It's going to extend stateless widget, which is it's part of the Dart framework. It's part of Flutter. A stateless widget, like we talked about earlier, is one that's just going to be static. So every widget is going to have a build class that we're going to override. The reason we call override is this is kind of a stylistic choice. You don't have to have that there, but it's telling us when we look at it that build exists within stateless widget, but we're rewriting what it actually does for my app. So in this case, build will return a widget because it needs to return it to run app. And it's going to take in a build context called context. Flutter handles what passing this in does automatically. What this means for you is that you can actually access the context. You don't have to write what the context is, but if there's some specific things about the widget, you can know it, like maybe its position or its color or something like that. So that's what context is used for. And within this build function, we're going to return that widget. So you can see clearly here that it returns a widget. It's a strong type language. And we're going to return that material app that comes from our library. So the material app is going to have a few parts. It's going to have its title, not too important. We might be able to reach that from context though, if you want to. It's going to have its theme, which is going to color some of the things. So all the widgets come together. It's going to color them based off our theme. So our primary swatch is essentially our primary color. And then visual density is just some different spacing type things. And then we have home, which is going to be our homepage application. And in homepage, we're returning a widget that's my homepage. So for title, it's just going to be a string. For theme, it's actually another widget, theme data, that has its own widgets, material color, visual density. Don't worry about that too much. And then my homepage is the custom widget that we're going to be focusing on. So in this case, we also pass it a title. That's the Fly with Flutter demo. And we're going to be using that title right here when we want to write into it. So we see my homepage is actually a stateful widget. So the difference between the stateful widget and the stateless widget is that the stateless widget is contained all right here. But the stateful widget is a part of this and the state itself, which is all this right here. So the stateful widget is just going to have the building for it. So it's going to have the title, and then it's going to have my homepage state that it returns, which is the state right here. And it's going to create that. So what this is telling it is telling you that when the state changes, it's going to call this state widget that you pass into it. So the state right here, this is where the actual code goes. So we have our function that I'm calling change color. And in change color, we're going to set the state. And what setting the state's going to do is if I didn't have set state right there and I just had it change the color, then it wouldn't re-render it. It would just do it. When you call set state, it tells Flutter, OK, I want to change the state and re-render it. So set state, we're going to take the color and we're going to turn it to something random. That's what this function does. So it's just going to change our favorite color to some random color. And then finally, we have our build function, which has a bunch of different widgets. Don't focus on this too much. This looks a little messy. Just notice the fact that I start with that scaffold to give me some structure. I have the app bar that's using the title of our widget. And then I have center, column, I have row, I have another column, and all that's doing is letting me really specify where I want to structure everything. And when Ray debugs, you're going to see what that looks like a bit more. So right here, this is what our app looks like. And you can see that the app bar matches our favorite color. But when I click it, it actually changes. So it randomizes the color. And because this is a stateful widget, I can change it dynamically. The thing is, though, the app bar gets its color from our theme, which belongs to a stateless widget. So because it's a stateless widget, it's going to keep everything static. The title won't change, the color won't change, none of that. Even if the value for it is changing, so the app bar value, the theme right here, is changing to our favorite color, but it's not changing the actual app bar because it's a state widget or a stateless widget. We don't want it to change. It's static. That being said, if we were to do something like a hot reload, which that manually re-renders everything but keeps all the information static, if we manually re-render it right like that, it's going to re-render it with the color that we passed into it. Now, that's not because it's stateful. That's because some external input changed, which re-renders everything. But as you can see, when we keep clicking it, this renders dynamically. Well, this has to be changed statically. And if we do a full restart, it's going to turn everything back to its default, which starts with the color black, because that was the initial values that we had set for it. And something you can do, Ray will get a bit more into the debugging. But if I stop this and then run with debugging, just to show you what some of the structure looks like, hopefully it should open the app and you're going to be able to see some of the rows and columns and the different outlines of the containers that I set up for it. whenever it wants to start. Sometimes it can take a little bit. So it's coming right here, starting up. It's built. All right, there we go. It should give me in just any second. All right, so we have this. We can click this dev tools, which is going to inspect it. So it's going to start those dev tools. It'll be on the right there. And then all I'm going to click, I'm just going to show one of these right here, show debug paint. If I click that, it keeps clicking out. You can see the outlines. So the first column is this big thing right here. And then I have that row. And then within that row, I have the text, and then I have another column to split it so I can have this stacked on top of each other. So the row is what's letting me put these two widgets side by side, and then that column within the row is what's letting me stack it on top of each other. And you can see if I kept calling rows and columns and rows and columns, I can get pretty fine-grained detail within it. In fact, I actually have a little spacer right here, which is this size box right here, which is just an empty widget that kind of spaces it. So I have height is 5. So if I didn't have that, the text would be like directly touching the circle right there. So that's the basic idea behind state and widgets and things like that. I hope that helped. I hope it's not too confusing. Sindhu's going to talk a bit more about layouts and things in that nature. So I'm going to pass over the control to her.
Thank you so much, Taylor. I learned a lot about widgets. So let me share my screen. Yeah, so I'm going to talk about layouts. And basically, layout is very important when you're designing a mobile application. And it actually designs the visual structure for a user interface, such as the UI for an activity, or it can be how you place your different boxes in the app. It is really essential to have good knowledge about layout widgets as they help us to build amazing UIs with Flutter. Flutter provides various layout widgets already inbuilt, which will save a lot of time if you don't want to like build them yourself, and if you know like which to use when. So there are two main layout widgets that are in Flutter. First one is the single child layout widget. As the name suggests, it can only have one child widget inside the parent widget, and the second one is the multi-child layout widget. So these are some of the single child layout widgets that are provided by Flutter. And according to the requirement, it comes with practice, so you know which to use when. Container is like the most popular layout style widget. This provides customizable options for size, like height and width, and painting as well as positioning. Padding widget will help you position pad some amount of depth for the child which you're placing inside it, and center will help you put the child widget in the center of the page, like Taylor showed you the uh, favorite color as well as the title to be like left side or right side. You can use align widget for that, and sized box can be used for defining a box with a specified size, or you can actually like have a child with specific aspect ratio, like 1:1, for like images which are in like Insta, uh, the profile pics. You can design your apps with those aspect ratio using the aspect ratio widget. So there are like many other widgets. Coming to the multi-chair widget layout, it is also very important because we use like rows, columns, grid views a lot whenever you are defining, let's say, like a flight booking application. Then you need to show the flights in the order of lists. So in that way, the list view can be really helpful. Or let's say stack widget will help you place some of the uh, details, or like you want to like place an image at the back side of your background of your application and have a particular title in front of it. So stack actually helps you have your like front that particular text to have a transparent format, and you can have a background which can be placed at the back of it, or have a grid format. So I'll just show you a basic example of how multi-share layout widget works. So here is a small tab which is having call, route, and share buttons. So the tab is basically a row widget, which is a three-child widget. And since it is a multi-child, we can put three childs inside, and that each has three again icons, and each icon will have one icon, the image of whatever buttons you have, and also the text you have for that particular icon. So if you see the widget tree for this particular tab, here is a container in which we place the row, and the row has again three children, three column widgets, and each column, since it is again a multi-shade, it will have two more children. One is the icon, you can place the image, or like you can, since you can like control each and every pixel of the phone mobile using Flutter, we can actually like uh, paint it out as well. And the other one will have a container, and that container has a text. And be sure like container is a single child widget, and you can only place one child inside it. Now that you know a little bit about multi-child widgets, you can go ahead and start developing your own apps. And now we'll see how to debug and test the code and deploy the code. So I'm handing over the control to Raymond.
Okay, thanks, Sindhu. Time to share my screen. All right, so thank you, Tyler, for talking about widgets and more about stateful widgets. And thank you, Cindy, for explaining the different types of layouts, like single child or multi-child layouts, and for the wonderful graphic that just helps visualize how layouts can be used to make your app more organized. So now I'm going to be talking about debugging, testing, and deploying, which are like things that you can do during like development and the late stage portions of your application. So for debugging. So first off, the typical ways you'd probably debug is by using dev tools, Android Studio, IntelliJ, the built-in Dart analyzer, or the built-in Dart analyzer for VS Code. And these different environments provide tools that help you debug. So as for dev tools, so the Flutter dev tools is just a suite of performance and debugging tools for Flutter. And some of the tools include like the Flutter inspector, the performance view, CPU profiler view, memory view, network view, and debugger. So more about these is the Flutter widget inspector is basically the powerful tool that helps explore the widget tree. So it helps you like understand the layout that you're using in your app and also try to find underlying layout issues. And you can also look at like the different traits or alignments, so like centering, padding, rows and columns. And for the performance view, it has timing and performance information for activity in your application. So it consists of the Flutter frames chart, the timeline events chart, and the CPU profiler. And inside the CPU profiler, you can record and profile a session from your Flutter application, and it just tracks how much work your CPU is doing. So it can tell like how efficient or inefficient your application is. And for the memory view, so when you're running a Flutter application, every allocated Dart object uh, 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 takes a portion of memory on the heap. So the DevTools memory page lets you peek at like how much memory your application is using at a given moment through snapshots. And snapshots is just a complete view of all the objects in your memory heap. So when you're on the memory view page, you just click take snapshot of heap, and then it'll just give you all the data of how much memory it's using. So yeah, and as for the network view just tracks the HTTP or HTTPS requests from your Dart or Flutter applications, so you can monitor the socket traffic. And as for the debugger, the debugger, you just like set breakpoints and then just step through lines of code as typical. So other like environments such as like Android Studio IntelliJ and VS Code, they have a Flutter enabled features. So they inside them, their extensions for the Dart language have an analyzer that already checks your code. And it checks your code by observing the type annotations. So type annotations is like when you, instead of using var or maybe dynamic, you actually state the type of the variable like int, text, a widget, or whatnot. And then if you have some sort of error, the Dart analyzer will highlight them and sometimes it won't even let you compile the code until you fix it. And when you develop, it's best to use debug mode so that you can use the Dart assertion statements in order to debug and make sure it runs smoothly. So yeah. And now I'm going to show a little bit about like how you can debug while we're working on your Flutter application. So right here, I'm in the main Dart file, and I think over here I can show you how like the Dart analyzer can work if you have the wrong type. So right now we have a list of integers, it's empty, but let's say we annotate it with the wrong type, like text. And as you can see, immediately the Dart analyzer picks up on this issue and just says it cannot be assigned to this variable text, the list. So yeah, you just fix that error. And then additionally, as you're running the code, like a typical IDE, you can just set breakpoints or whatever and step through it and whatnot. So I'm going to run in debug mode, and hopefully this compiles and builds quickly. But when it's running, I'm going to show how you can access the Flutter dev tools from VS Code. So yeah, it's building. All right, yeah, so it's working. So while it is running, you can click the command palette, and then you can just do Flutter. And it's already in my autocomplete, but Flutter open DevTools, and you can choose which tool you want to use. It seems to be updating currently. So Tyler earlier was in the widget inspector, so that allows you to check the widget trees and just look at the different details about each widget. But for me, I'm going to go to the memory page. So looking at the memory page, it starts off with this warning that I'm running in debug mode. So the warning just basically means that since it's debugging, it uses resources to help allow you to use the debugging features. So typically, you want to add the -- profile flag so that it's more closer to an actual build in terms of performance. But for Flutter, it's always in development, and my emulator is an x86 machine, so Flutter currently doesn't have support for a profile mode in x86, so I would need an x64 emulator. And right now it's just giving a live feed of the memory that I'm using in the maximum memory. And then here you can take a snapshot of the memory, just get more details at a certain moment. So yeah, just a glimpse into the debugger. And feel free to check the documentations for what else you can do with the Flutter dev tools. It gets really in depth and there's a lot to explore. So yeah. So now that I've done a debugging demo, I'll explain more about testing. So testing is not a very glamorous part of development, and some people often skip it because like it's more fun to just implement new features or get all the cool, sparkly, just flashy, just functionality. But generally, as you add more functions or functionality to your code, it becomes harder and harder to test manually. So with testing, you can make these automated tests that can ensure that your app performs correctly before you publish it, while retaining your current features and bug fix velocity. So as for automated testing, it typically falls into 3 different categories. So first off, we have the unit test. It's the easiest to set up and doesn't require that many dependencies. And what it does is just test a single function, method, or class. In terms of Flutter, when you make a unit test, it doesn't really test like any of the widgets. It just tests like a certain just a Dart class. But as for the next type, the widget or component test, which would be its equivalent in other languages, this just tests a single widget in Dart and makes sure that it works as intended. And lastly, the integration test, which is the largest test. It requires an emulator to run, and it tests the complete app or a large portion of the app, and it goes from an end-to-end use case that a user would typically go through when they use the application. So yeah, when you run an integration test, you try to run it with like a driver, so that helps like just isolate it from avoid like different or skewed results. And then lastly, continuous integration. This is just like a type of method that allows you to run tests automatically when you push new code. So when you push new code, if you set up a continuous integration, it provides instant feedback on whether your code worked and if it caused any new bugs that could uh, just stop the app from running. And if you want to look more into continuous integration, I suggest that you look into Travis, App Circle, or Cirrus. So yeah, now I'm going to show a couple tests that have been written and explain more on like their functionality. So over here, we have favorites test start. So, oh yeah, before I go into the test, I have to explain how to set up testing through the YAML file. So first off, you have to install these new dependencies with the Flutter driver, and SDK, Flutter test, SDK, and the provider. And then once you have these new dependencies in your YAML file, if you just control or Command S on Mac, on VS Code, it will automatically just get these dependencies. But if you're on a different IDE, you might have to run a pub get just line of code in the terminal to get these dependencies. And after you've done that, then you can start writing tests. And in this models favorites.test start, I've written a couple of simple unit tests. So over here, when you're writing unit tests, you can group similar tests into a group that's good for Flutter. So, and you just give them a description. So this is the app provider tests. And then I create a favorites object. So it will just be like inside the application is favorites widgets. And I'm testing a new item should be added correctly and item can be removed correctly. So here you just create a number, you add the number and you expect that the favorites now contains the number. And then here you add a number, expect it contains a number, remove it, and then you expect it doesn't contain a number. And then there's two ways to test this. So first you can write Flutter test models dot favorites test start, and then just load them. And as you can see, it only took 2 seconds to run both these unit tests, which means it's very fast to just write a bunch of these unit tests to get as much code coverage as possible. And the easier way to run these tests is just to go in the editor and just press run right here. And then yeah, it'll say that this test passed, and you can just run this one as well. So after unit tests, I'm going to show you some widget tests that have been written. So over here, when you write a widget test, you basically, what's it called? Oh yeah, you have to use the test widget function. So instead of the test function. So basically you give it two parameters. You give it the description, and then you pass in the callback. And the callback just has asynchronous functions because when you're like interacting with the widget itself, it doesn't happen instantly. So you have to give it some sort of time to let the application respond to these, let's say, taps or scrolls and whatnot. Yeah, and pump widget just basically kicks off each process by telling the framework to mount and debug a particular widget that you specify as a parameter, just as you would if you're just rendering it in your emulator. So first off, we have the group homepage widget tests. So I just wrote like 3 different widget tests here. And the first test tests if the list view shows up. So you pass in the callback, and then you say that the tester should mount and debug the home screen. And then once that's done, you expect to see a list view, and which was written in the main code, and if you expect to find 1. And the other test is to test the scrolling. So again, you pump or mount and debug the home screen. They expect to find item 0. So after it's built up, you expect to find this in your widget tree. And then afterwards, you use the fling function. So, I mean, when you're testing, there's a lot of functions that you may not recognize. So it's important to just go through the documentation and just look for specific tests or functions that you might want to explore. But basic fling just helps you scroll. So basically when you scroll, you just scroll down a little bit, and then it pumps and settles, so it mounts and debugs after scrolling, and it expects you to find no item 0. So like it's just gone from the render. So yeah, just test if that works. And lastly, for testing icon buttons, you just mount and debug the home screen, and you expect to find no favorited icons. So like all the favorited icons are uh, just see-through. So there's nothing there. And then you tap one of them. So you tap the first one, the one with the favorite border, and then you pub and settle. So you just wait for like 1 second. Then you find the toast or some great piece of text that shows up. It says added to favorites, and you just expect to find one. And then now after doing that, you expect to find a favorited icon, and then just find one, and then tap it again, pub and settle, and then you expect it to find the new toast removed from favorites, and then expect to find nothing. So it's a lot of lines of code to test something that's quite simple, but usually that's pretty much required for widget tests because Flutter just has a ton of widgets, as what Tyler mentioned. So yeah, and I'm going to test them by running it on the terminal. So yeah, all the 3 tests pass. And again, you can just run them from in here if you so choose. And lastly, the most involved test is the integration test. So when you're usually the best practice thing you want to do when you're running integration tests is to actually create a new directory called test driver instead of putting them into the test folder. And it requires the Flutter driver dependency as I showed you in the YAML file. And before you can test with an integration test, you have to instrument the app. And instrumenting the app basically means configuring the app so the driver can use the GUI and the functions for creating and running an integration test. So the app.dart file here is used to instrument the app, and the app_test.dart file is the actual integration test. So over here in the app.dart, it just says to allow you to run a Flutter driver extension. So this just allows the driver to begin running when setting up for the integration tests, and it calls the main function of the application. So now the app is running. So now we're in the app underscore test start, which is the actual integration tests. And first off, we just create a Flutter driver variable. Then we set it up. So we connect the Flutter driver and assign it to this variable asynchronously because it could take a while. And then over here, this is like after all the tests are complete. So it just tears down the driver if it is not null or still running. And this just waits until after the tests are done. And here are the 2 integration tests that I wrote. So first off, you just have the description and then the asynchronous callback. And then you just find the type by list. And then you have a timeline. And you trace the scrolling action. So you scroll down and then you scroll up. And then afterwards, this is unique to integration tests, is that it writes the summary of what happened during your test to a file, and it also writes a timeline what went down to a file. This is a JSON file, and it will show up in your build after it's done. So you can see some of the earlier examples of just me experimenting with this. And here is the other integration test, the favorites operation test. So what I did here was I created a timeline again, and I waited the trace action. I found the icon keys, and then the driver will tap all these 3 icons and wait for the text added to favorites each time. And then you tap, or the driver taps the favorites icon, which would be this. And then you find the 3 remove icon keys, and then you tap each one, and then you wait for it to be removed. And then afterwards, you would get the timeline summary and then write the summary to the file. So when you run these integration tests, you have to use a different set of commands. So here in the terminal, you have to flutter drive and then target test driver app dart. So yeah, I would add the -- profile flag, but again, my emulator doesn't have the functionality to run that. So when I run it, it'll give me errors. And as you can see, it's actually trying to use the emulator to run these tests. So yeah, it's building currently. Now it's installing it. It's testing the scrolling down, scrolling up. And yeah, this is just a profile warning. And now all the tests have passed and the driver is teared down or torn down. So yeah, that's basically a demo on testing. And I hopefully you guys can implement some tests on your own as you develop your Flutter application. So after testing, I'm going to go over how you can deploy, which is the final and perhaps the most exciting stage of developing an application. So first off, when you deploy for Flutter, you can deploy to uh, different applications. Each application has its own set of steps and rules you must follow because Flutter is cross-platform. But when you deploy it, it actually has to finally target a specific platform. So yeah, I'm going to be going over how you can deploy for Android and for iOS. So first off, when you deploy for Android, uh, you have to sign your app. So you have to create a key store, reference this key store from your app, and configure signing in for Gradle. And Gradle is just a file that the app uses to build the application. And there's commands to do this, and I encourage you to look into documentation for more details as you can get involved. And secondly, you have to shrink the code with R8 in order to make it just more take up less space, so it's easier to just transport between either you and a tester or the Google Play Store. So R8 is just a code shrinker from Google, and it is enabled by default when you run now. So you don't have to explicitly say it. But when you're using R8, it can significantly extend the compile time. So it'll take longer to just build your app every time you want to build it. And third, you want to review the app manifest. So this just describes like your app's name and the permissions you can have and like the ID. So you have to make sure those values are correct. And then fourth, you have to review the build configuration. So you have to make sure the ID is correct as well, because this is how you're going to reference it forever from now on if you deploy it. And unless you change the version code or version name, and you have to make sure like those are uh, consistent as well. So you always start from one and just go up. Maybe a big change, you turn it to two and whatnot. And then lastly, the most important values you can set are the minimum SDK version, compile SDK version, and target SDK version. So minimum SDK is the minimum API level for Android that your app can compile and run correctly on. And then the compile, compile is the typical like API level that the app is compiled on, like for this build. And then the target SDK version is actually like the maximum API level that your app is designed to run on. And then fifth, you want to build your app for release. Well, when you aim to build your app for release, there are two options you can choose. You can either choose to build it as an APK, or you can choose to build it as an app bundle. So what's the difference between an app bundle or an APK? Well, basically, an app bundle is more of a publishing format, while an APK is just a typical packaging format that you can just transport between users without using like the Play Store. But the Google Play Store prefers the app bundle because if you have an app bundle, this app bundle can deliver optimized APKs depending on what device the client has. So say if you have a Pixel or if you have a Samsung, this app bundle can recognize that and then just deliver a more optimized version. That it can be smaller and it can run even faster. So that's why Google Play prefers that. And then lastly, you want to publish to the Google Play Store, and there's a link there. And this link will contain just different checklists to help you launch your app. It has information for deploying to different devices and how to test different things and make it more appealing to potential users. So yeah. And also, if you want to deploy, there's a thing you can do called code obfuscation. So a code obfuscation is just basically you want to modify the app's binary so that it makes it more difficult for people to understand just the binary code. And this will prevent people from reverse engineering your code and figuring out what you're doing. So if you ever want to like sell your app like for profit on the market, you want to look into this. But if you're just experimenting for fun, you just put it on GitHub. You don't need to obfuscate and whatnot. So now that I've talked about deploying for Android, I want to going to discuss deploying for iOS. So when you want to deploy for iOS, you have to review the Apple App Review Guidelines and just take a look at the Apple Developer Program. So when you try to deploy an app on the App Store, you have to ensure that it follows the App Review Guidelines, or it can be rejected, and then you just have to try again later. But also, if you want to deploy to the App Store or work on App Store Connect, you have to enroll in the developer program. And this costs $99 a year, but offers a bunch of features such as like Test Flight, which you can find testers for your application, and like ways to manage your uh, banking information, sales reports, or just all the apps that you're working on and the life cycles. So first off, when you want to deploy for iOS, you want to register your application on the App Store Connect. And the two most important things is to register a bundle ID and create an application record. And so you just define your app name and description when you're registering. And yeah, this will just help complete your application record. And secondly, you want to review the Xcode project settings. So even though you're developing with Flutter, you have to make sure the settings in the Xcode are just correct and as what you desire before you publish it. So you want to just make sure that your bundle identifier, your display name, the signing for just uh, ensuring that the app is just running correctly, and the iOS deployment target. So this is similar to the minimum SDK version or compile SDK version on Android, and it just describes the minimum iOS version that your app supports. And then third, you want to update the app's deployment version and version number if you change them in the Xcode project settings. So yeah, you just go into the Flutter project directory and just go to the iOS and then app framework info and then just update those. And then fourth, you want to create a build archive. So a build archive is one of the two ways you can deploy on iOS. You can deploy in a build or a build archive. And a build is just basically the compilation of the source code. But the build archive is the overall package that contains the app and also other related files. So then this is like similar to the app bundle where you can distribute more optimized versions. And then lastly, you can release your app on the test flight and if you so choose the App Store. So test flight, as I said earlier, it just allows developers to push their apps and get testers to test and provide feedback. So this is good to see if your app can eventually pass the app review guidelines. And then if after submitting on test flight, if you think your app is good enough to pass the guidelines, you can upload to the App Store. And then there's a review process that'll take a while to complete. And if you pass the review process, Apple will notify you through an email. And then voila, you're on the App Store now. So yeah, that concludes the Fly with Flutter Part 2 workshop. And I'd like to thank you guys for taking the time to listen to Tyler, Sindhu, and me, and about like the widgets, layouts, testing, debugging, and deploying. And if any questions, just make sure to join the socials which will be posted in the chat, and then join the Slack to learn about upcoming events and workshops. And then this video will also be posted on YouTube. So thank you guys.